Hey everyone, it's Jim from Valves and More, an online vintage tube store. And today, in Tube Lab number 33, we're going to take a look at the Willsenton R8 build exposed. But first, caution everyone, electronics and tube amplifiers can have very high voltages present, which can be lethal. Exercise extreme caution when working around them. Always consult a professional technician when in doubt. And if you're enjoying these videos, please hit the like button and subscribe. Okay, we've done a lot of tube reviews with the R8, so I thought, how about we have a wee look under the hood and see what we can find. It's got a nice bottom plate with lots of ventilation, good heavy. I think this is probably 1/8 aluminum. So the first thing we see when we get underneath is, oh, we got a voltage switch. Now, my household voltage is 120. And there's a label over here at the IEC inlet where the power cord comes in and plugs in, stating that the amp is set for 115 volts AC, which of course works fine anywhere around 115. So if your household voltage is 119, mine tends to be 119.5, it'll work just fine. It will work fine at 120. So what's with that switch? Well, let's just see. 230 volts. Aha. So what that tells us is that this amp has a universal transformer. Now before I forget, I'm going to switch it back. So if you happen to switch this, if you moved, let's say, to a different country that had a different household voltage, make sure you make a new label up so that whoever gets their hands on this amplifier after you knows what it's set for. In fact, you can even make a note on the label that there is a switch under the cover. Now before you go any further, in fact, before you do anything, you've got to ask yourself, are you confident enough to take the lid off of an amplifier? And if the answer is no, you don't know what you're doing, then don't take the lid off. And if the answer is yes, I think I know what I'm doing, then proceed with caution. First of all, the plug has to be unplugged right from the wall. Everybody got that. You didn't need me to tell you that. Next, you need to find out if there's residual voltage hiding in things like these large filter capacitors and all these other little capacitors that are floating around here. So grab your voltmeter, switch it over to DC, jump in and check the contacts on your filter, your biggest capacitors that you can find. And here we've got 0. Here we've got 0. Now if you find a couple of volts DC floating around, that's fine. That's not a danger to you in any way. And you can check a few other capacitors, these electrolytics over here. Now, if you found 300 volts sitting on top of these things or more, you've got to discharge them before you can proceed safely. And you need a capacitor discharge tool. And all that is a large wire wound resistor, and it does a controlled short. Now Blue Glow has a fabulous video on how to make one of these things. And basically you just come in on the positive and negative of your biggest capacitors. You'll get a little spark. That's normal. That's just the energy snapping on to the short here. Remember, you're shorting out your capacitors in a controlled fashion. So the positive side is grounding out through your tool. So do them both. You can do some of the smaller ones. Go back with your voltmeter, check it again to see if the voltage is safe, and then you can proceed. Okay. So our power comes in from the wall here. It comes all the way up here to the on-off switch. It's just out here in the front. It's hard to see. It's over here. I can't get the whole thing on camera and allow you to see any detail. So in this corner here, we've got, I believe this is the timer warm-up, and basically it just keeps the volume off until I think we run 20 seconds or something like that. It allows the tubes to warm up before you can start to listen to your music. From there, our AC comes all the way over here to this point, and you can see we've got a cover, we've got a lightning bolt and a caution, and that's there for a reason. Even if we can't read what this says, it says be careful. There's high voltage present, and the symbols tell us that. But we've already checked, and we've discharged the capacitors if necessary, and we've unplugged the amp, so we're good to go. So let's look underneath the cover. So here's your power transformer. It sits on the top of the amplifier, nestled in the middle, and it's going to take our household voltage and step it up to whatever voltage we need to rectify to DC. So it could be somewhere around 375, 400 volts. I didn't actually check to see what it is, but it'll be a much higher voltage. That AC voltage is rectified, which basically means that we make DC out of it. The DC is what we run virtually all of our amplifiers on. AC is what we put the audio onto our amplifiers on for amplification. And the beauty of amplifiers is that the AC audio signal can ride on top of the DC in the right circuit topology. Isn't that neat? So we have to clean up a really raw DC signal, and for that we use a choke. So we have a filter choke here of 4 Henrys, which is actually fairly small, or low in value. But there's a school of thought that says that the higher Henry you have, the higher the filtering you have, but also the more resistance you have. So it's a balancing act, and some audiophiles claim that the lower value chokes actually give a better sound. They don't choke the B plus, the DC. Pardon me, I couldn't resist that. Anyways, so that helps, and these big capacitors, they do a big chunk of the filtering. They are 330 microfarad, 450 volts. So that tells us that our B plus is lower than 450, right? Quite a bit lower, because you need a good margin for error. So that's providing our DC to power the amplifier. What about the AC side of it, the signal side? Well, it comes in over here at the back at these jacks. It goes into what is basically a switching board. You see, I don't know if you can see the ribbon. You can certainly see it over here. See that ribbon? It comes all the way from the input side up here to the input selector, and then it goes back, and it basically tells the switching board here what the input is that we're going to take. And from there we basically get a shielded left and right cable that comes off of here, and it goes up to our volume control. It's a motorized volume control, and basically that's just a volume control with a little motor on it, and it allows us to have a remote control. Let me see if I can move it down just a bit. This thing is so heavy, it's hard to shift around. So we have a left and right audio signal coming into the volume pot, and then we have a left and right coming out, and then it goes into our first tube, which is the 6SL7. So this is a stereo amplifier, a stereo integrated amplifier. So we have a left side over here, and we have a right side. The only thing that we really share is the power transformer. So that first stage, that 6SL7, that's our voltage gain, that's our preamp tube. From there we go over to here to the 6SN7, and the 6SN7 does two things in the circuit topology that is this amplifier. It splits the phase so that we have half the audio signal going to one side of our power tubes. We have two power tubes here, and half going to the other side. But it also drives the power tubes as well. So we have something called a preamp tube, and we have something called a driver tube. And basically what they're doing is they're raising the voltage to a point at which the power tubes will be happy. And that signal fluctuation that they feed the power tubes drives the power tubes and drives the output signal. We're going to go over this really fast. There's just so much to do. Now, I did a previous tube lab and I goofed up the circuit topology, some of it. I'm going to take a really fast look at what I goofed up. Now, initially I thought that the 6SN7 was just the phase inverter tube, but I got that all wrong. So, in brief, our voltage is amplified here at the first stage, at the 6SL7s, the two halves. The first half amplifies the voltage significantly. This is a high gain tube. The second half of the 6SL7 takes a low impedance signal off the cathode. You can see here we were nominally in the positive phase. Coming off of the plate we invert, we're negative. Coming off the cathode we don't invert, we're negative. Coming into our first half of the 6SN7, remember these are two tubes inside of one envelope, two tubes in one envelope. On the first tube here, when you take the signal off the plate, you invert it. So now we're back, we're actually in phase with the beginning signal. So that's 1/2 of the push-pull amplifier design. Now where I goofed it up is when we take the signal off the cathode here, the phase doesn't invert, but this cathode here is feeding the audio signal to the cathode of the other half of the 6SN7. And this is called a grounded grid amplifier, this side here. And here you can see this is normally where the audio signal would go onto the grid here. And here you can see it's grounded through this 0.33 microfarad cap. That's how it gets its name. Now when the signal, in this type of circuit topology, when the signal comes off of the plate, it's amplified, but it doesn't invert. And you say, okay, so now we're positive here, we're negative here. So that's how the audio signal has been split into two separate 180-degree out of phase signals. So two halves. That goes into our EL34s or our KT88s, and each tube amplifies half the signal. It gets recombined here through a special output transformer, and here you can see we started off with a very small signal, and it kept on getting bigger and bigger until it becomes this very large, low impedance, 408 ohm output signal, and it's completely unified. The two halves of the audio signal become one unified signal. Okay, I'm going to put this revised schematic up. A big thank you for A. Patel, who did he did this up. He actually took apart, he didn't take apart an R8, he opened it up, and he basically did a schematic up on what he had found. And I goofed up what he had done here. I actually thought he had inverted the tube by accident in the diagram, and in fact what he did was he got the pin numbers wrong, not the orientation. So the cathode is exactly where it should be and the plate is where it should be, but the pin numbers actually are just wrong. He goofed those up. So anyways, that's no big deal. And I'm going to go back to the previous tube lab in which I did this up, and I'll write up a little explanation. Maybe even I'll have to redo the tube lab, I don't know. We'll see if I have time. Okay, so here we go. We've got our pair of right output tubes, EL34s, let's say, and our pair of left output tubes. They're working together on that audio signal. We just talked about that. The two halves are being amplified. And they come over here, and underneath, I'm not going to take this apart, but underneath these boards here are the output transformers. And from there, the signal gets recombined. The impedance changes dramatically. It comes in as a high voltage, high impedance, low amperage signal, and it comes out on the other side at our speaker terminals as a low impedance, high amperage, low voltage signal. Isn't that fun? And let's see if you can see. Let me get that back here for you. There you go. So here's our binding posts, and you're either 4 ohms or 8 ohms with your negative stays common, of course. So one set for one channel and one set for the other channel. And I think you can just about see it. Let me just tilt it up. We've got some really nice heavy gauge wiring coming through to the output contacts here. In fact, let's just talk in general about the quality overall of the construction. It's excellent. My hobby is designing and building my own amplifiers, tube amplifiers and preamplifiers. And I'm strictly an amateur, but I like to do nice work. And I can tell you that I couldn't do as neat a job as they've done here. Now this is factory assembled, and they're probably building thousands of these units. This has become a very popular amplifier. And I know because I'm selling lots and lots of sets, complete sets in many cases, to new owners. And I'm getting lots of good feedback, which helps me think a little bit about my tube selections. But if you look at the solder joints, they're excellent, they're neat, there's not a lot of flux. Flux is what helps the solder make good clean contact. If you look at the, for example here, this is a negative ground bus bar. In here it's nice and straight, it's neat. We've got good gauges of wiring. Where we need heavy gauge, they put heavy gauge. And some of the circuits, the boards, would be a little hard for an amateur like me to troubleshoot, but the basic tube circuit wiring would be dead easy to work on. Down here you can, I don't know if you can see it, but the heater wires are really nicely twisted, orange and yellow pairs. They're down low, up against the chassis, which is the way they should be. And I mean, overall, I can't see anything to complain about. It looks like they've used good quality components throughout. I mean, these electrolytics here, actually I didn't even talk about that. This center tube is in the B plus, in the DC power supply side of things, and that tube, the 6SN7 in the middle, that is actually not handling any audio. It is in a filter capacity. And these electrolytics here, these are Nishikon. Those are good quality brand name electrolytics. That's nice to see. Now these are polypropylene caps right here. They're rebranded Willsenton. But you know, there's no reason to think that they aren't decent quality as well. They're certainly not, certainly don't appear to be junk. So I would give the build quality a two solid thumbs up. And of course, if we could flip this over easily without a crane, we could talk about the aesthetics. But really, what I wanted to talk about was build quality, and to take a quick look at the circuit topology as it was built, so you could get a sense for how things go. Let me just get the lid back on here. This week saw some really nice tubes come in. Let's take a quick look at a few of them. Now, a whole bunch of Slovenia 12SN7 bad boys came in these boxes. Now, there's no way that a bad boy made in the 1950s still has a box that looks like this. So what the heck's going on here? So there's two options. One, these boxes are late surplus boxes from, let's say, the early 1980s, before the tube era ended, what I call the second tube era. or their reproduction. And there are a lot of reproduction boxes out there. There are people that just specialize in making new boxes. Let's have a quick look at this tube. Now, many of you know that one of my favorite 6SN7s is the Sylvania tube, and this is, in my opinion, this is one of the best 6SN7s ever made. Now, this is the 12-volt version, so it's not, you can't plug this into, well, you could plug it into a 6SN7 slot, but it's not going to do very much because it needs a 12-volt heater. But one of the reasons why I'm buying the 12SN7 bad boys is because the 6SN7s are so hard to find at any price. Many of them come in, they're noisy. Many of them come in, they test really weird. They're 70 years old, they're antiques, and finding affordable new old stock, it doesn't happen anymore, folks. But you can occasionally find nice new old stock 12SN7s. So when I build preamps these days, I'm building universal heaters, so I'll be able to switch over to a 6-volt heater or a 12-volt heater. And I've got some prototype amps that I've talked about in the past. Anyways, a bunch of these came in. Take a look at this. Now, they were advertised at a very reasonable price, non-test. They were coming in from France, so not tested. And look at that. Pin 2, which I think goes onto the plate, is snapped right off on one half of the tube. So that's garbage, unfortunately. But quite a few of the tubes were good. What else came in? That's what happens. It happens, folks. So look at that. Really, this is factory packaging. 6C, 8C, that's the Russian Cyrillic for what we would call a 6S, 8S, which is also a 2C, 2.2, and it's got a whole bunch of other names. But this is basically, this is the high frequency version of a 6J5, but with the connections moved up here, with the grid connection and the plate connection moved to the top. Anyways, I've got a monoblock amplifier design in which this will be the driver tube, I hope, but it'll be a universal design, so you could wire it up to take a 6J5, or you could wire it up to take one half of a 6SN7. Neat, eh? Anyways, that's in the works. I'm still waiting for the output transformers. They're coming in from Asia somewhere, probably Hong Kong, and it just takes forever. You pay those guys, when it comes to big transformers, you pay them, and then they make them for you. Isn't that neat how that works? And then 2 months later you find them, you know, in your mailbox eventually. Okay, and I saved the best to last. Now, for the R rate, one of my favorite 6SL7s is the Melts tube. And I've been having a hard time keeping these in stock in matched pairs. The people buy them so fast. And what happened is I got in a nice bunch of new old stock Melts tubes. Nice clean looking tubes, testing good, nice and strong. On my tester, nominally 80 is new old stock. So 86, 81, those are good numbers. Very nice clean pins. So I managed to make up 8 pairs, and I swear I had them in the store for no more than a half an hour, and somebody bought the first pair. Anyways, if you were hoping that I would get some Melt 6SL7s back in stock, some new old stock tubes, they're in there. They probably won't last the weekend, so jump on them. They're not cheap tubes, but frankly, I have a feeling that whatever you pay today, 3 years from now, they'll be twice as much. The price has just been going up crazy, and I don't know how much longer I can buy them, to be honest with you, because once the tube gets hot. Before I started featuring the tube for the R8, it was a little known 6SL7, and once I started talking about how good it sounded in the R8, the price doubled literally in the span of a month. So, anyways. There you go. Well, if you stay all the way till the end, here are some discount codes to help you out. Remember, I've got flat rate shipping around the world of $20. And if you spend $150 or more after discount, the shipping's on me, folks. Stay safe, everyone. This is Jim from Valves and More signing off. Cheers, everyone.